Exercise 76, question number 18, which is actually overleaf on page 160. It's quite an awkward question, this one. If I remember rightly, this sort of idea is actually used to check the diameter of a rod or something by putting it into a groove and measuring this distance x, which is how far down the groove it goes. But I've certainly seen it in welding workshops. So what we have is a cylinder that's inside this groove with a diameter of 40 millimeters, and it's dropped down so it's a distance x below the level of the top of the groove, which is 70 millimeters wide. And the angle at the bottom of the groove is 50 degrees. What we need to do is try and calculate what x is. Well, it's going to involve some trigonometry. It's going to involve using the sine, which is opposite over hypotenuse, and the tangent, which is opposite over adjacent. That idea, as well as the idea of similar triangles at the end. So, the idea of similar triangles is the idea that if I have two triangles that have the same angle here, then this triangle that's inside this one, then the ratio of that side to that side is the same as the ratio of that side to the whole of this side, y, from here to here. So a to b, which is the inner one, a to b, that ratio is the same as the ratio of x to y. That sort of idea of similar triangles. Let's see if you can have a go at it from the diagram that I started off here. I'll put in the radius, which is 20 millimeters, which always hits at right angles to the side of the groove, so we can form a right angled triangle. What we need to do is try and find the length of this line, which means we can then find the distance from here to here, and then we can form another right angled triangle by drawing this distance across here, so that there would be a right angle, and then we can find this distance from there to there in that triangle and compare that with this distance right across, or from halfway to there, which is 35 millimeters, and then use the idea of similar triangles to end up with a value for x. So have a go at it and see how you get on. I'll run through the solution below. So first of all then, if I know that this is 20 millimeters, and I know that this angle here is 25 degrees, I can work out what this distance here, the hypotenuse of this right angle triangle is, because I know that the sine of 25 degrees equals the opposite over the hypotenuse. So therefore the hypotenuse equals the opposite side over the sine of 25 degrees. And the opposite side is going to be 20 millimeters. So therefore h equals 20 millimeters divided by sine 25 degrees, which turns out to be 47.324 millimeters. So that's this distance here, h. Now I can add on the radius of the circle to get this extra distance here to the top. So then that whole total distance will be, which means we can then form this right angle triangle here. So this distance from the bottom of the groove to top of cylinder is 67.324. I just add on the radius of the cylinder because there's distance from the middle to the top. So now we have another right angle triangle. So if I draw that right angle triangle here with a right angle there, I've got this distance here which is 67.324. I know this angle here is 25 degrees and I'm after this distance here. Call that y. So this time we're using the tangent. So tangent of 25 degrees equals opposite over adjacent, and we're after the opposite side, so the opposite equals the adjacent times the tangent of 25 degrees, which is 67.324 times the tangent of 25 degrees, which turns out to be about 31.394. So y is 31.394. And if we now look back at the original distance, for this triangle here going up to the top, that's 35 millimeters, and we've got 31.394. So the ratio of the two similar triangles can now be used to find x. So if we draw the similar triangles, we've got drawn very well. So this similar triangle, we've got that this inner triangle 31.394 opposite over this, the adjacent, that ratio 31.394 over 67.324 must be the same as the ratio of 35 to 67.324 plus this extra distance x. So we can write down that ratio, the ratio of x plus 67.324 to 35 is the same as the ratio of 67.324 to 31.394. So now it's a case of algebra to calculate what x is. Multiply both sides by 35 equals 67.324 over 31.394 times by 35, and then finally x is going to equal, subtracting 67.324 from both sides, 67.324 over 31.394 times 35 minus 67.324, and that should give the answer in the textbook. Not an easy question.